Now you know the difference between curve and surface. Also some additional data with it. Telling you about gradient. Suppose f is a function of x, y and z. Then gradient of f is terms like this called del by del x, del by del y and del by del z. This thing with f and just add the directions I, j and k. This I represents this quantity in the x direction. Subsequently j and k represent these quantities in y and z directions respectively. Now these quantity can also be written as fx, fy and fz. Now the directions like I, j and k can be ignored and this can be written in this form also. So that is it. Now del by del x is called the partial derivative of f with respect to x. Similarly, del by del y of f and del by del z of f are the partial derivative of f with respect to y and z. Now we come into the topic of partial differential equations with those basics and clarity with mind. Now we have surface and tangent, and a perpendicular to the tangent at a point was like p, q and -1. Here this p is called del z upon del x and q is called del z by del y, where z is a function of x and y. Now if we have the space x, y, z coordinate, we are having a surface like this in the green color. Suppose we have a point FAB, then tangents can be drawn at this point like this. Again, another tangent can also be drawn like this. We can name the tangent like T1 and T2. There are also infinite possibilities to make tangents passing through the point FAB. Now with so many tangents we can do so many things. So that was a pictorial view, but what does this del f upon del x and del f upon del y represents mathematically? Suppose you have a function of xy. Let's say z is a function of xy and you want to find del f by del x and del f by del y. This thing can also be written as f partial differential x, and this is partial differentiation of f with respect to y. And how will they look like is, there is change in x but no change in y, and while doing the differentiation we treat y as a constant. Here we take limiting factor h goes to 0. This will represent partial differentiation of f with respect to x. Similarly, when we are talking about partial differentiation of y with respect to x, there is no change in x, but there is change in y. So the differentiation looks like this. There should not be any confusion, so let's replace h by h bar here.